Next type of function to look at are these graphs with what we call asymptotes. Here's a random curve I've drawn here, tried to get every type of asymptote I could think of there. So an asymptote tells you what happens at extremities, because you can't actually get to infinity. So it sort of tells you what's happening out there, if you could get there. So you could have a vertical asymptote. Now that one usually happens when we have an exclusion in the domain. There's a value that you can't have. So vertical asymptotes will occur if the limit as x approaches a particular value of a function ends up being plus or minus infinity. Which is what would happen, let's say, here's our hyperbola, y equals 1 on x. Now as you approach 0, that value will get closer and closer to infinity. If you were to substitute in smaller and smaller and smaller numbers into x, then the actual value of y gets bigger and bigger and bigger and bigger. So if you see that happening, yeah, that's a vertical asymptote we got. Now, functions will never touch or cut the vertical asymptote. They never will, because it's an exclusion in the domain. You can have horizontal asymptotes, and there's one there. Horizontal ones is now what happens when x is plus or minus infinity, telling you what happens out there. Now, it is possible, and you'll notice in my diagram I've got it cutting the horizontal one there, because remember, it's telling you what happens out at infinity. So if it cuts it somewhere else, that's fine, it can do that. But the curve will go towards the asymptote. They always bend towards the asymptote. And then you could have what we call an oblique asymptote, and that usually happens when both the x and the y value are approaching infinity. So you get it at some sort of an angle. So that's the one I tried to do on the left there. That curve, both the x and the y value are shooting off, well, the x value is going to negative infinity, the y value is going to positive infinity. So that's what we call an oblique asymptote. Oblique asymptotes are straight lines. You could have curves that are asymptotes as well. It's certainly possible. Basically, any function that approaches infinity could be an asymptote. Functions can touch, so that's what I was saying before. They can touch the horizontal and oblique ones, just not the vertical ones. Well, as I say, the most basic of them all is y equals 1 on x. It's what we call our rectangular hyperbolic function. And the reason it's called that, rectangular, is because those asymptotes, it's got a horizontal one, the x-axis, it's got a vertical one, the y-axis, and they are at right angles to each other. So that's why it's called rectangular hyperbolic function. If you were to plot data, you're doing an experiment, and you notice the points fit this sort of shape, then it's demonstrating inverse variation. So as one value is getting bigger, the other value is getting smaller, and vice versa. But just like we saw with every other function, we can create every rectangular hyperbola from y equals 1 on x via rotation, reflection, translation, all those sorts of things. How do you recognize it? Well, if I'm looking at a function and I notice one pronumeral is in the numerator, so y is, because it's like saying y over 1, and the other is in the denominator, I've probably got some sort of hyperbolic function here. Exponential functions, they also have asymptotes. Now, it depends on what the base is. If we have a positive base greater than 1, that's your classic shape of the exponential, where it's so 2 to the power of x, 3 to the power of x, something bigger than 1. It starts shallow and then increases very quickly. If that base is in between 0 and 1, then it flips the other way. I sometimes call it the backwards exponential. You don't have bases of 1, because if you think about it, 1 to the power of anything is 1. So it would just be a straight line. And you don't have bases that are negative, because with that we'll just jump around. You get a chaotic thing, because a negative number to a positive power would be positive, but a negative power to a negative power would be negative, and it just goes up and down, up and down. It's a mess. So recognizing the exponential, pretty easy to recognize. One of the pronumerals would have to be in the power. Another name for the power is exponents, and that's why it's called an exponential, because that's an exponent. And, well, I said that before, the base is positive but not equal to 1. Okay.